Using prime factors to compare numbers. Once numbers are factored, it's possible to compare them on the basis of their common factors. Three such comparisons are relatively prime, greatest common factor, and least common multiple. Two numbers are relatively prime if they do not share any prime factors. Even numbers cannot be relatively prime to one another since they share the factor of 2. However, a composite number, which by definition is not prime, may be relatively prime to another number if none of their prime factors are the same. Are 15 and 8 relatively prime? All right, so 15 does not have a factor of 2. It does have a factor of 3. 15 divided by 3 is 5. So the prime factorization of 15 is 3 times 5. 8, however, is 2. 2 times 4 is 8. 4 divided by 2 is 2. So it's 2 times 2 times 2. 2 cubed. Since they don't have any prime factors in common, they are relatively prime. The greatest common factor, GCF, also known as highest common factor, HCF, is the largest factor that two or more numbers have in common. It's the product of all their common factors raised to the lowest power they appear in any of the numbers. The GCF of any group of numbers is never larger than the smallest of those numbers, since it has to be a factor of all the numbers. To find the greatest common factor, factor each number into its prime factors, identify the common factors and the lowest power to which each is raised in any of the numbers, multiply the common factors together, with each raised to the lowest power it appears in any of the numbers. You are planning a party and want to give your guests bags of candy. You have 24 chocolate bars and 36 lollipops. What is the greatest number of bags you can make such that each bag has the same amount of each kind of candy, with none left over? This calls for finding the largest number that can divide evenly into both given amounts, the greatest common factor. The GCF will be smaller than either amount since it has to be a factor of both numbers. All right, so we make our prime factorization tree for 24 and for 36. So you can see here that 24 is 2 times 2 times 2 times 3, or 2 cubed times 3. 36 is 2 squared times 3 squared. So 2 is a common factor, but we're going to use 2 squared since this is the lowest power that appears. Over here it's 2 cubed, so we go with the lower one. We put 2 squared in here. 3 is also a common factor. Here it's 3 squared and here it's 3 to the first, so we're going to use just 3. 2 squared is 4 times 3 is 12, which means that 12 bags can be made, each of which will have 2 chocolate bars and 3 lollipops. Knowing that we're able to make 12 bags, we can then equally divide the 24 chocolate bars and 36 lollipops into those 12 bags, yielding 2 chocolate bars per bag, because there's 24 chocolate bars divided by 12 gives us 2 per bag, and 3 lollipops per bag, because there's 36 lollipops divided by 12 bags gives us 3 lollipops in each bag. Find the greatest common factor of 12 and 16. On this slide, I'm going to go through making the trees, the prime factorization trees. Remember, the prime factors are 2, 3, 5, 7, and so on. All right, so 12 is divisible by 2. It's 2 times 6. 6 is divisible by 2. 2 times 3. And we are done. We have 2 times 2 times 3. We can rewrite that as 2 squared times 3. 16 is divisible by 2. 2 times 8. 8 is divisible by 2. 2 times 4. 4 is divisible by 2. 2 times 2. And we are done. So this is 2 times 2 times 2 times 2, which is 2 to the 4th. So let's go to the next slide to see what the greatest common factor is. Okay, so you can see that 2 is the only factor they have in common. This one has a 3, but this one doesn't, so we ignore the 3. Here we have 2 squared. Here we have 2 to the 4th. We take the lowest power. So 2 squared is the greatest common factor between 12 and 16, which is 4. Find the greatest common factor of 60 and 72. All right, so I'm just going to go ahead and write my lowest prime numbers. Probably won't need more than that. 60 is divisible by 2. It's 2 times 30. 30 is divisible by 2. 2 times 15. 15 is not divisible by 2, but it is by 3. So we get 2 times 2, 2 squared, times 3, times 5. All right, 72 is divisible by 2. What is 72 divided by 2? So we got 2 into 7 is 3 times, 6, 1, 12, 6, 36. 36 is divisible by 2, and that is 18. 18 is divisible by 2, that's 9. 9 is not divisible by 2, but it is by 3. 3 times 3. So we have 2 times 2 times 2, so that's 2 cubed times 3 squared. All right, so 2 is in both of these, but 2 squared is smaller, so we're going to go stick the 2 squared in here. 3 is in both of these. 3, and here we have 3 squared, so we're going with the lower power, 3 to the first, times 3. 2 squared is 4 times 3. The answer is 12. All right, and here's the answer. The greatest common factor is 12. The 2 squared and 3 and 60 are the lowest powers of 2 and 3 present in the numbers, so they are factors of the greatest common factor. 5 is not a factor of 72, so it is not a factor of the greatest common factor. Find the greatest common factor of 36 and 90. All right, so we have our prime numbers here, 2, 3, 5, 7. 36 is divisible by 2, that's 18. 18 is divisible by 2, 9. 9 is not divisible by 2, move on to 3, yes. 3 times 3, and we are done. So therefore we have 2 squared times 3 squared. All right, now 90. 90 is divisible by 2, it's 45. 45 is not divisible by 2, so we move on to 3. 45, is it divisible by 3? Well, 4 plus 5 is 9, which is divisible by 3. So yes, it is. I could probably do this in my head, but let's do some long division. 45 divided by 3, 1, we got the 3, 1, 15, 5. The answer is 15. So 45 divided by 3 is 15, and 15 is divisible by 3, 5. So we have 2, 3, 3, and 5. So that's 2 times 3 squared times 5. All right, now there's a 2 in both, but this is the lower 2. So we're putting 2 to the first power here. We have a 3 squared in both. Put that in there. 5 is not over here, so we don't even think about it. 3 squared is 9 times 2, 18 is our greatest common factor. And there you have it. The greatest common factor is 18. A multiple of a whole number is the product of the number and any non-zero whole number. A multiple that is shared by 2 or more numbers is a common multiple. So multiples of 6 include 6, 12, 18, 24, and so on. Multiples of 14 include 14, 28, 42, and so on. The smallest common multiple of 2 or more numbers is the lowest common multiple, the LCM, of those numbers. This is also called the least common multiple. The LCM will always be at least as large as the largest of the given numbers, since it has to be a multiple of both. The lowest common multiple of 6 and 14 is 42. So if you list all the multiples of 6 and all the multiples of 14, what's the lowest number that's in both lists? That's the lowest common multiple. It would have been easy to miss that 42 was the lowest common multiple in that case. As the numbers get larger and the lists of multiples get longer, finding the lowest common multiple in this way is both time-consuming and unreliable. You may miss the lowest common multiple when comparing the lists of multiples. The faster, more reliable method is based on prime factorization. First, factor each number completely. Write each factor as a base raised to an exponent. Identify the common factors. Write the common factors raised to the highest power to which they appear in either number. Multiply those factors together to find the lowest common multiple. Note that the greatest common factor is found by raising the prime factors to the lowest power to which they appear in either number, then multiplying them together. So the greatest common factor will be lower than the least common multiple, which uses them raised to the highest power and then multiplying them together. The greatest common factor will be no larger than the smallest given number, while the least common multiple will be no smaller than the largest given number. The words greatest and lowest may be confusing in that the greatest common factor will always be equal to or lower than the lowest common multiple, and that can seem backwards. Just keep in mind that the reason for that is that multiples can be infinitely large, so you're looking for the lowest of them. Factors are limited in size, so you're looking for the largest of them. Find the lowest common multiple of 6 and 8. So first we factor the numbers into their prime factors. We have 2 times 3 and 2 times 2 times 2. So 2 appears, so we include 2, to the highest power. So here we have 1 2, here we have 3 2's multiplied together. So we take 2 to the third and stick it down here. Then we also have a factor of 3. Now this is different than before. Over here we don't have a 3, but when we're finding least common multiples, that doesn't matter. We're going to include each one. So 3 also gets put down here. Multiply them together and we get 24. Now if we had made our lists, so 6 times 1 is 6, times 2 is 12, 18, 24, 30, and so on. 8 would be 8 times 8 is 16, 24, 32, and so on. You would find that the lowest number they have in common is 24. So you could make your lists and find the lowest number, or you could use this method, which is more reliable. Find the lowest common multiple of 18 and 24. So here are my lowest prime numbers. Okay, so 18 is divisible by 2. 2 times 9. 9 is not divisible by 2, so we move to 3, and there we go. We're done. 2, 3 times 3. 24 is divisible by 2. 12 is divisible by 2. 6 is divisible by 2. And then we're done. 2, 2, 2 times 3. So here we have 2 times 3 squared. Here we have 2 to the third times 3. So our least common multiple is going to have a 2 in it, but to the highest power, to the third. And it's going to have 3 in it, and the highest power is squared. So 2 to the third is 8. 3 squared is 9. The answer is 72. All right, and here is the answer, 72.